Hello everyone, and welcome to the second webinar in the virtual testing series, C-NCAP 2024 Far-Side Protocol. In this webinar, we'll cover correlation and injury scores. My name is Rory Bradshaw, and I'll be taking you through the webinar today. So to start with, I'll give you an overview of our agenda for this webinar. I'll begin with a summary of the protocol requirements and prerequisites. Then we'll take a quick look at the reporter templates we've added support for this protocol. And then we'll walk through the C-NCAP 2024 Far-Side Protocol flowchart that we've created to help you through the process. And we'll show you how Oasys LS-DYNA workflows can support the complete virtual testing process. And then I'll show you some software demonstrations on how to use workflows within Primer, THIS, and Reporter. To finish with, we'll have a time of Q&A. So feel free to type any questions in the chat box, or if you're watching this back later on YouTube, feel free to comment on this video and our support team will endeavor to get back to you. So to start with, let's look at the required physical and virtual crash tests. This protocol is fairly confusing with lots of requirements, so I thought it would be good to start with a high-level summary of what's needed. Firstly, you'll need to have conducted a physical side pole test where the barrier is hitting the driver's side, and that's required as part of the side pole protocol assessment, which is outlined in Appendix D of the C-NCAP protocol documents. Next, you'll need to conduct 8 simulations of the working conditions. We'll cover them in the next slide. And then one of those will be randomly selected by C-NCAP to be conducted as a physical test, which will be used to perform correlation. Then, depending on whether your vehicle has airbag protection or not, you'll need to conduct an airbag symmetry validation. And there are 2 options for this. Either a fully physical test, option 1, where you conduct a physical far side pole. That's essentially a reflected test of the physical side pole, where the driver is assessed this time instead of the front passenger. Or option 2, which is fully virtual, and this requires what is called the Virtual Assessment Certificate to be performed. So in order to obtain that, we need to conduct a virtual side pole assessment, which is correlated against the physical side pole. And then once we pass the virtual assessment certificate, we can perform the virtual far side pole assessment as per option 1. So let's take a look at the working conditions then. So there are 8 working conditions. Working conditions 1 to 6 are with a world SID occupant, and working conditions 7 and 8 are with a SID 2S occupant. As I mentioned before, one of these is going to be randomly selected, so depending on which one is selected, you'll need to perform a physical test and correlate against it. Now these are sled tests, and the head excursion will be measuring these tests, and one important parameter that you'll need from your physical side pole test is the distance to the red line from the head center of gravity, which I'll cover in the next few slides. So this is very similar to the Euro-NCAP protocol as well, if you're familiar with it. But essentially we have these different color bands which correspond to the amount of head excursion during the sled test. The blue line is the center of the vehicle, orange line is the center line of the seat, and that is assumed to be symmetric with the head center line at the beginning of the crash. Then the yellow line is 125 millimeters inboard of the orange line, and the green line is 125 millimeters inboard of the yellow line. Now, in automotive assessments, all of these can be automatically calculated, but the red line needs to be input manually, which I'll show you how to do later on. The maximum possible score that can be achieved is conditional on the amount of head excursion and also on whether the vehicle has airbag protection measures or not. The table shown on the right, table 3-36, is showing the scoring for different levels of head excursion based on a vehicle which does have airbag protection, and you can see that there's a different tolerance based on if the red zone is greater than 125 millimeters from the orange line or if it's less than 125 millimeters from the orange line. All of these scorings are automatically calculated for you in the reporter templates. If you don't have any far side occupant protection measures, i.e. no airbags, then the scoring is much more stringent. However, you won't need to perform the airbag validation. However, you won't need to perform the airbag symmetry validation as you don't have any airbags. So a consequence of having airbags is that you might benefit from better scoring, but you need to prove that the behavior is symmetric for occupants on both sides of the vehicle being impacted on the far side. So now let's take a quick look at the reporter templates that we support for the C-NCAP Farside protocol, and these can be used to generate reports of your results for the full protocol. Now I'm covering just the English language reports, but there are also Chinese language reports which are covered in a separate webinar, but the approach is much the same. Now I'm going to quickly open up Reporter and show you this interactively. So we have these filter options on the left-hand side, and I filtered by the C-NCAP protocol here, and also by the English language. And then we have these 1, 2, 3 options here, which correspond to the flowchart, which I'll show you in a second. So to start with, we've got the SLED working condition assessment templates, and you can see that they're color-coded to help you find the right template to use. You can also further filter on SimVT to find the templates required for correlation, or Automotive Assessments for those for the injury scoring. There are two variations, the World SID and the SID2S, and additionally, depending on which of the working conditions is selected by C-NCAP, you'll need to run either the working conditions 1 to 6 or 7 and 8 plus CFA templates in order to calculate the correction factor A. Next, we have the dual occupant penalty templates, and these are used to calculate the penalty based on the passenger performance. And there are two different types of passenger, an ES2RE and a World Sim passenger. So you need to select the correct template based on which passenger you used in your physical sled test. And then thirdly, if you require an airbag symmetry validation, we have the SimVT templates for the virtual assessment certificate, and we've also got the far side dual occupant assessments, and these are essentially the reflected cases of the side pull assessment. And to finish with, we have the summary template, which can be used to summarize the total scoring. And we also have the quality criteria and the VTC videos templates, which will be covered in the next webinar. So as I mentioned before, we've created a flowchart which helps you work through the whole process. Now those three options that I showed you in Reporter, 1, 2, and 3, correspond to the three boxes you can see on the left-hand side. So the first of those is the scoring item, which you can see here. To start with, C-NCAP will randomly select a working condition to be physically tested, and if it's 1 to 6, then we follow the left-hand route, and if it's 7 or 8, then we follow the right-hand route. Then we can set up the Automotive Assessments data in Primer, we can perform the correlation fitting index in SimVT, and we can also use the reporter template to generate a report of the correlation fitting. If the correlation fitting passes, then we can move on to our occupant injury, and we can use the reporter template to evaluate the correction factor A, which is based on the test score divided by the simulation score for the chosen working condition. If it failed, then we get 0 points and we fail the entire process. After calculating correction factor A, we proceed to calculate the injuries for the remaining 7 assessments. So if we had working condition 7 selected, then we would assess working conditions 1 to 6 and 8 using the appropriate reporter templates. Next, we move on to the deduction item, and this is the second section. Now, in reality, this will be a physical test that will be used to calculate the deduction with a penalty of up to 1.5 points. But when you're performing in-house testing, you can use the provided reporter template to assess the front passenger and evaluate the deduction items. There are two variants, a World SID and an ES2RE passenger, and the one you use needs to match the physical side pull test. The third box is another deduction item. So first, the flowchart asks if the vehicle contains the center console airbag or any of the airbag protection. If it doesn't, we skip this whole process because airbag symmetry validation can't be performed on a vehicle with no airbags. If it does, then we need to choose again the correct route left or right depending on which front passenger was selected for the physical side pull test. So in this case, if we took a World SID front passenger, then we'd follow the left-hand side. We can set up the protocol in Primer and assess it in SimVT to determine if we pass the virtual assessment certificate. And there's also a reporter template which can be used to report the virtual assessment certificate status. If we don't pass the virtual assessment certificate, then we lose all the points, so we get a penalty of 0.5. If we do, then we move on to carrying out the far side pole assessment, which is essentially the reflected assessment of the side pole, and there's a penalty of up to 0.5 points depending on the injury score. The injury can be computed either in Automotive Assessments or with the reporter templates for the World SID or the ESTRE occupants respectively. And finally, you can use the summary template in order to evaluate the overall score. That score is a combination of the 7 simulation scores multiplied by the correction factor A, plus the test score, and then divided by 8 to get a score out of 8. And then the penalty factors are subtracted with a maximum penalty of 1.5 for the passenger and a penalty of up to 0.5 for the airbag symmetry assessment. And that gives us an overall score for the C-NCAP far side protocol. Before I move on to some demonstrations, I'm just going to mention briefly the concept of workflow user data. So if you've used the workflows before, you should be familiar with it, but I'll just explain it for those who might not. So a typical workflow starts in Primer by setting up the user data, and then this data is accessible in the post-processing stages. When carrying out an automotive assessment, the starting point is to create Automotive Assessments user data in Primer. That data can then be picked up by other workflows, which themselves might have additional metadata. So now I'm going to move on to some demonstrations to show you how to work through the whole process. And in this demonstration, I'm going to assume that working condition 7 has been selected, that my vehicle does have center console airbags, and so airbag symmetry validation is required. And I'm going to select option 2, which is the fully virtual approach for the airbag symmetry validation. I'm also going to be using vehicles where both occupants are World SID dummies. For the dual occupant penalty, I'll be using a side pole simulation model rather than using a physical test, which would be used for your final results. So the process starts by defining your user data in Primer, which I can show you how to do just now. So I'll open the model in Primer, and I'll click on Workflows and select Automotive Assessments. Then I'll select the Farside plus VTC protocol. It's worth saying that from V22 onwards, this will be renamed to Farside SLED. Then I'll select the C-NCAP regulation, and I've got two options, either SID2S or the World SID. Because this is working condition 7, I'll leave it as SID2S. Then I'll select the model units, and I can add the occupant. It's pre-filtered by all the SID2 occupants we support at the moment, and I know that this is using the version 4.3.5 occupant, and it's the right-hand side one. I'll then select the head offset node for the C-NCAP calculation, and this should be the topmost node of the head. Everything else is pre-added for me, so I'll click on Add. Now I can define the structures. So I'll select the B pillar, the lap belt, shoulder belt, a sled, and I'll select by part set, and sled accelerations from the B pillar. And then this vehicle doesn't actually have an airbag, so it's okay to leave that blank. But if it does have an airbag, then you can define that by selecting the airbag part. So now I'll save that to a file, Automotive Assessments, Workflow Data, and close. Now I'll quickly show you how you can create LS-DYNA ISOME data. So you can open this up in Primer and then click on Calculate Distance, and it's automatically calculated the green, yellow, and orange line distances based on the head center of gravity. And then I can add the distance between the head center of gravity and the red line, and this will go in the ISOME header file 850 here. And that value would come from the physical sled test. I'm also going to change the virtual testing ref ID to working condition 7 and then save that to a file. Now I could save it to the same JSON file, but I like to keep them separate, so I'm going to save it as LS-DYNA to ISO MME and then workflow data. And then I can close that down. And now, if I open up THIS and select Workflows, I can see that I have Automotive Assessments user data being picked up, as well as LS-DYNA to ISOME and SimVT, and that's because SimVT doesn't require any additional data aside from the data in Automotive Assessments. Now we've created our user data, and I've shown you how to create the ISOME data as well. I'll now show you how you can export that data to ISOME format in THIS. So we'll select the LS-DYNA to ISOME tool, and then we can click on the calculate button and it will automatically extract all of these details from the analysis files. I can fill in the other fields if I want them to be populated, and then I'll select an output directory and click on export. So once they're successfully exported, I can then see that I have all of my channel data that's been exported for me here. Next, I'm going to show you SimVT, which can be used to perform the correlation fitting index. So we'll go back to THIS, and in THIS we'll now select SimVT. And in order to correlate, we need to have two models, or a model and some test data. So I'm going to import the test data. And I could import the ISOME data I've just written out, but that would give me an exact correlation. So I'm actually going to use some test data. And I can select the MME file or the CHM file. They'll all work, so I'll just select that. And it's been imported, and because it was test, it's automatically been selected as the reference test. And because the workflow data had the C-NCAP SID2S protocol selected, it's also automatically selected working condition 7 to 8 protocol here for me. So all I need to do now is click on all, and these matched up channels will be correlated. And then I can plot them and visualize the results. Now, if I expand the ratings, you can see that not all of the ratings are good. For example, here the Y acceleration is actually below the threshold, but because of the weighting that's applied, the overall sensor score passes. It's also worth pointing out that only the head excursion and the neck forces and moments are a requirement for the individual sensors. The other sensors are considered to be monitored because they're not scored individually, but instead they are combined to make an average sensor score, and that is actually automatically done for you in Reporter. So we can export a SimVT settings file. Just call that working condition 7, and then save that, and it will be working condition 7.simvt. And now if I open up Reporter and I select selected working condition scoring items and also SimVT, I'll select working condition 7 and 8 for the SID2S occupant. And when TS opens, I can select that SimVT settings file that I just created, and it will automatically populate the other fields. Now you might want to change the output directory to keep your results tidy. So by default, it's in the same location as the settings file. So I'm going to output the results in a folder called SimVT report, just to keep it tidy, but you can call it whatever you like. And I'll select that folder and click on run. And it's going to extract all the results for us in a report. So we're saying this report can also be automated using the command line arguments. So you can actually generate this report automatically after you have run a simulation. And details of that are on our online documentation. So here's the overall report. We can see the correlation fitting index pass, so that's great. That's all we really need to know. But we've got details of the individual ISO scores, the weightings, and then if we go to the subsequent pages, we can see the actual corridor plots. And then there's a summary of everything at the end. Now I can choose to save that to a PDF or a PowerPoint, and I'll just save it as working condition 7 correlation fitting index. So I've shown you the plotting in SimVT, and the two options, correlation fitting index, I followed this working condition 7 and 8 option here. Next, I'll show you the injury scoring in automotive assessments, and it's worth pointing out that we need to enter in the red line value here in order to calculate the red line intrusion. So now back in THIS, I can close SimVT and open up Automotive Assessments and click on the head, and I'll select the driver head excursion here and enter the red line distance. So I'll enter 850 here. And if we have airbags, we can select the countermeasure option. Then I'll import the test data. And I'll plot all of the assessments for the body. And if I minimize this, I can see the assessments have been conducted. So I've got the head hic, and then the chest compression, the head excursion plot. We can see the test and the simulation are within or before the green zone, and the abdomen compression as well. I can also see all the results for these and highlight them. Now if I go to Reporter, and I'll open up a new template. If I change this to Automotive Assessments, I can now see the Automotive Assessment templates. I'm using working condition 7 and I want to calculate the correction factor A, so I'll be providing the ISOME data and the model data. To start with, I'll give it the working condition number. Then I'll select the test data. The distance from the head CFG to the red line. And now I'll select the simulation data. So I'll select the keyword there. It gives me an option to choose a default file, or I can configure it in Primer to save it elsewhere. Note that if you've got a long file path, you might need to save it elsewhere, or you'll hit the file length limit in Windows. In this case, I'll just press yes to use the default option, and then THIS will essentially do what Automotive Assessments did and generate the images to be put into the report. So now I generated the report. I can see the head excursion plot, I can see the scores, I've got full marks for this particular assessment, and the correction factor A is 1 as a result. The subsequent pages show me the simulation and test scores for the different body regions, and then I have the head acceleration and the chest and abdomen compression plots as well. I can choose to save that to a PDF, and I'll save that inside the results area, and I'll just call that working condition 7 CFA. So I've just shown you the occupant injury for working condition 7 to calculate the correction factor A. And next I'll show you one of the templates you need to use for the remaining 7 working conditions in order to calculate the simulation scores. I'll show you this for working condition 1, but the approach is much the same for the other working conditions. In this case, I'll select the working condition 1 to 6 template, and I'm going to do it for working condition 1. The distance from the head to the center line, 850 again. And now I'll go to working condition 1 and select the results there. I'll use the default here. And this report just uses LS-DYNA data, so there's no ISOME data required. It calculates the head excursion and generates a report to give me the score. In this case, the score was 4 out of 8, and that's because the head went into the yellow zone. And because the airbag wasn't defined, there's no countermeasure. I'll then save that report in the results area, and I'll just call this working condition 1 report and save. Next, I'll show you the dual occupant penalty for the side pole passenger. As I mentioned before, I'll show you this for the simulation case, but in reality, you'd be using the physical side pole test in order to calculate the penalty. So with that primer, I'll drag in the side pole simulation model. So I've loaded in the side pole model with 2 world-sid front occupants. And if I open up the Automotive Assessments data, I've already defined this. So I've got the world Z documents preset in here, and you can see we've got side poll, C-NCAP, and the world Z option. There's also the world Z ES2RE option if you have a different front passenger. So if I open up the reporter, I can now change it to the dual occupant penalty option. And we can see both of those variants, the ES2RE and the world Z passenger. So I'm going to select the world Z option, and then I can select the side poll simulation keyword. I'll accept the default location, and it will generate the report for me in order to evaluate the dual occupant penalty. So in this case, I pass all of my criteria, so I have a penalty of 0. Now moving on to the airbag symmetry validation. Now since I don't actually have an airbag in this vehicle, this is actually not required, but for the sake of completeness, I'm going to demonstrate this for you. So we'll pretend that we do have an airbag, and we've got a world SID front passenger, so we'll be following this left-hand route. As I've shown you before, in Reporter, the easiest thing to do would be to select the third option under the C-NCAP 2024 far side drop-down. Now, the virtual assessment certificate is comparing the physical side poll with the simulation side poll. So if you calculated the dual occupant penalty using the simulation, then you'll have already have set up the user data in Primer, and that's what we're going to use. So we can reuse that, but the difference is we'll select a different reporter template in order to evaluate the results. We can also open SimVT in order to perform the virtual assessment certificate. So I'll show you that first of all. I'll take you back to the model in Primer, and then I'll open the model in THIS. And if I click on Workflows, the user data has been picked up, and we can see SimVT is also available. So I'll select that, and the virtual assessment certificate option is automatically selected because of the user data assigned to Model 1. So then I need to import the ISO-ME data for the physical side poll test. So I'll select that data here. And then I can select all to correlate those channels. And we can see that they've all passed the criteria. So the threshold is 0.5 for these. And I can plot them as well to see how they behave. So even though some of these individual scores might fail, the overall sensor score is a weighted combination of the ISO scores, and it's weighted by the dominant magnitude. So because the Z component of the acceleration is dominant and it correlates more closely than the X and Y, we see that the head meets the 0.5 threshold. If I save the SimVT settings file, and I'll save it in the side poll simulation area, and I'll call this virtual assessment certificate. Then I can go to Reporter, then open up a new template. So I'll now select option 3 and select SimVT, and I'll see the virtual assessment certificates here. So I'm using both world SID front occupants. So I'll select this, and then I'll select the SimVT settings file that I just created. I could create a new output directory for this. I'll call it virtual assessment certificate. And then click on Run, and it will generate a report, which I can save into that folder. So we see we passed the correlating fitting index, so we've passed our virtual assessment certificate. We'll save that to PDF, and then we'll go back to the flow diagram. So we passed the virtual assessment certificate, so we go to this question box here, and in this case, we have a reflected vehicle. So what was our front passenger now becomes our driver. So if we had an ES2RE front passenger, we now have an ES2RE driver. But since we had both world SID front passenger and driver, we follow this left option here, and we'll select the purple occupant option. So we'll go to Reporter now, open up a template, and we'll now select the far side dual occupant option here, and we'll select the far side results. We'll accept the default location, and then the overall results are calculated, and we have no penalty in this case. We can save that report to a PDF, and this is the airbag symmetry penalty. So now finally we can generate the summary template. Now the summary template works by finding all of the reporter variables files of the other templates that we've generated. So I'll go to the directory and I'll need to do a bit of rearranging in order for this to work. So firstly, for the far side poll simulation, I'll go into the results area and I'll copy the reporter variable up one folder so that it can be picked up when I select the webinar folder as the summary folder. I'll also do that for the side poll simulation. I'll copy the reporter variables one folder up. So that's both the penalty items accounted for, and then for the working conditions, I'll show you it for working condition 1, and I'd repeat that for working conditions 1 to 6, and also for working condition 8. And then for the working condition with CFA, I'll grab that as well and place that in the working condition 7 folder. Once I've got all of the reporter variables in the correct location, I can then go to reporter, and then I can open the summary template. And this explains that we need to have all the reporter variable files in the output directories in the same folder. So I'll click OK. I'll select the overall folder, and then I'll also select a summary folder to output the CSV and XLSX files to. And our overall score has been calculated as 3.75 out of 8. So total score, so summing up working conditions 1 to 6 and 8 multiplied by the CFA of 1 gives us 22 plus the 8 for the test condition, that gives us 30. We divide it by 8 to give us 3.75, and with no penalty points, that's our final score. To finish with, I'll show you the documentation we have online for this, which you can use to follow the approach that I demonstrated in this webinar. So we have the flow diagram, and then each of these sections is hyperlinked to separate sections of the documentation so you can follow the steps. I hope you enjoyed this webinar. You can check out our other webinars using the link on the screen, as well as other training courses. And don't forget to follow us on LinkedIn and follow our YouTube channel. And make sure you subscribe to our newsletter so that you can hear all that's happening. Feel free to contact our support teams using the email addresses